Okay. All right, guys, so we're doing 2.6 today. Yesterday we had a shorter class in C period, so as long as we get through everything there, maybe one extra one will feel good. We will not finish 2.6 today though, so you will not have any homework. So another day with no pre-cal homework. How fun is that? So we're gonna do it starts, you're looking at homework, I think. Yeah, so get your notes out. It should just start right under the last problem we did. So we're doing 2.6 now. And this is a shorter like part of the chapter, but it doesn't feel like it rolls together as well. I feel like each section is kind of its own idea. And today we're mostly dealing with rational functions. I don't know if you guys remember reciprocal functions, rational functions from our BFF graphs, but that's what we're doing. So everything we're looking at today is a fraction function, okay? I'm just gonna make a few notes kind of like off to the side. You can put them wherever feels right on your note paper, but I just want to like write a couple things down. I believe with these rational functions, it's a review. I think you guys did this back in algebra 2, so I'm just going to make kind of notes off to the side. So reminder, this is our rational function. Another word we could use a reciprocal. That might have been the word we used more when we were doing our BFF functions. And the basic function of this is y equals 1 over x. That was one of our BFF graphs, right? You remember what that graph looked like? Good, we're all kind of put our little hands up. I see like a lot of just like little C's, right? Little C curves right there. So I'm gonna draw a graph of it just so I kind of remember what the basic graph looks like. It's two little C curves and one's in the first quadrant and one's in the second. And this was one that I told you, we just have to know that there are asymptotes. There are asymptotes, a vertical asymptote at 0, and there's a horizontal asymptote at 0. Okay. When I graph these, I really need 4 pieces of information. I want to figure out what both my asymptotes are, vertical asymptote, horizontal asymptote, and then I want to see what my intercepts are. Do I have any x-intercepts? What are they? Do I have any y-intercepts? What are they? Okay, so I believe that you've done this before, but we're going to just kind of make like a little chart over here to remind ourselves how to do those things. Okay. The first one is, let's think vertical asymptote. Does anyone remember how we find the vertical asymptote of a function like this? Is it what? H. No, not H. That's vertex. The bottom is going to be set equal to 0. So we're going to set the denominator equal to 0. So denominator equals 0. Okay. Now horizontal asymptote, there's 3 different options for that one. And I don't know if you'll remember as we do them, but there's like one of them we do most often. Okay. So your options here are if your horizontal asymptote, if you have like 1 over x or the denominator is bigger, has a bigger exponent, then your horizontal asymptote there is just y equals 0. Is this ringing any bells? Okay. If you have an x on top and an x on bottom, if your exponents are the same on top and bottom, then it's just going to be y equals the coefficients. If you have more space, you can write more of coefficient, but I kind of ran out of space. And then the last option, which we haven't done much with, but we are going to do, probably not today, we'll probably do it tomorrow or next class, is if the exponent on top is bigger than the one on bottom, we have a slant asymptote, and we have to do synthetic division. So I'm actually going to do this. I'm just going to write synthetic division. So we're going to have a slant asymptote, and we're going to do synthetic division to find that. X squared over x. I've just got this guy right here is just like an arrow to tell me what we're doing. We're doing synthetic division. I think we've already done a little bit of this, and I do believe you did this in algebra 2, right? We're kind of remembering this stuff. Okay. Now, the other 2 things I need to know are x-intercept and y-intercept. Do you remember how to do either of those? How do I find my x-intercept? I want to switch, can I? Kind of, yes. On this one, you can think about plugging 0 in for y. I'm gonna set the numerator equal to 0 on this one. So plug 0 in for y, and the bottom doesn't matter because if the numerator equals 0, then that makes that whole fraction 0. And then the last one, the y-intercept, just like we think about for the x-intercept, plug 0 in for y. This time we're gonna plug 0 in for x. So we're gonna plug 0 in for x. Okay, I think that's enough steps for right now. So this is kind of the key I'm going to keep referring back to. We're going to use this for basically all that we're doing today. Does anybody have any questions on VA or HA, X or Y intercept? Yeah, Will. This one right here, coefficients. Yep, that a fraction of the coefficients. So let's do 2 examples, right? Let's get into this first one. I'm going to leave space for a graph. So I'm going to put a graph right up here. And then I'm going to do all my work down here. So I'm going to do VA, I'm going to have an HA, I'm going to do an x-intercept, I'm going to do a y-intercept. If I need more room, I'll deal with that later. Okay, so we're dealing with that gray function right up there. My VA, remember we set our denominator equal to 0, so I'm going to set x minus 3 equal to 0. So my VA is x equals 3. I'm going to find everything first and then graph everything. Is that okay? So we're going to find all of our pieces and then we will go graph them. So x equals 3. Okay. Horizontal asymptote. Now we look at our exponents. I've got x over x. Are those the same? Perfect. That means we're going to do a fraction of the coefficient. What are my coefficients here? 1 and 1. So we're going to do y equals 1. The constants are going to come into play later. That right now we're just doing coefficients. Okay. Now we've got x-intercept. What did we do for x-intercept? That's our numerator. So set our numerator equal to 0. X plus 1 equals 0. And then I solve for x and I get x equals -1. Now my y-intercept, we plug a 0 in for those x's. You can do that work. I also think if you plug a 0 in for x, it goes away, right? 0 plus 1 is just 1. 0 minus 3 is just -3. So my constants, basically, the fraction of my constants is your y-intercept. So in this case, it's going to be -1/3. So my y-intercept is -1/3. Once we have these 4 pieces of information, we're going to go graph them. So I'm going to come up to my graph up here. I like to graph my asymptotes first. So let me give myself some little guidelines. I've got 1, 2, 3, 4, 1, 2, 4, 2, 4. So I'm going to graph my vertical asymptote at 3. And my horizontal asymptote at 1. My y-intercept is -1, so I'm gonna go to -1 on the y-axis. And then my, x-intercept is -1. My y-intercept is -1/3, so I'm gonna go to -1/3, which is just somewhere between 0 and -1. I'm not gonna get a ruler out and be like, well, you give me -1/2, not -1/3. I don't care, just put it somewhere between 0 and -1. All right. I have enough points now to know where one of my curves is. One of my curves is kind of in this bottom left quadrant. So I'm going to draw my little C curve down here. I don't have any other points. Do you know where my other points are going to be? On opposite side. I like to think of it catty corner. So if it was on the bottom, now it's going to be on the top. And if it was on the left, it's on the right. So kind of the exact opposite of where we were. So somewhere up here. And as long as you do a curve, it doesn't really matter. Shall we do the next one? All right. I'll walk through this one with you too, and then we've got two more that I'll have you try on your own in a second, but let's try this one together again. So I have my graph, I'm getting that set up. I'm gonna get my horizontal, vertical little spots out too. Now, one thing we can do on this one that we couldn't do on that last one is to factor my starting equation. We can factor that down. So if I were to take anything out, or if I were to simplify this, that x squared minus 1 becomes x minus 1, x plus 1. And then the bottom, I can first think about taking a 2 out of everything. So if I factor 2 out, I get 2x squared minus 4. And then can we factor x squared minus 4? Yeah. 2 times x minus 2 times x plus 2. Now, you don't have to have factored this out because nothing cancels. We'll talk about what that cancel term does in a little bit, but nothing cancels, so nothing really happens by factoring it out. I just think it's going to make it easier when I have to set the numerator and the denominator equal to 0, because now I already have it in factored form. Okay. So again, since I can't cancel anything, it's not that important that you do it, but I just thought it was important to point out that if you can, sometimes it is helpful to factor out. So now I'm going to go do my pieces. Vertical asymptote, what do I do for vertical asymptote? Denominator equals 0, so I get x minus 1 times x plus 1 equals 0. And so x equals, oh, so sorry. Did you guys tell me the bottom too? And I just messed up. I got really excited. I'm so sorry. Okay, let's try that again. 2 times x minus 2 times x plus 2. Is that the right one now? Now my zeros, I feel like most of us have got this, but in case we don't, you know that starting 2 doesn't do anything. That doesn't count as a 0. There's no x there. So it's just a constant. You can just ignore. He just goes away. So my only factors are positive 2 and negative 2. That means I am going to have 2 horizontal asymptotes or 2 vertical asymptotes. Is that something you guys have seen before? 2 vertical asymptotes? Hopefully. If not, I'll remind you, but hopefully we've seen 2 vertical asymptotes before. Now horizontal asymptote, what am I looking at? Not quite, just a numerator. That's my x-intercept, my coefficients. I'm looking at my exponent, so I've got x squared and I've got 2x squared. And so since the x squares are the same, then I'm going to go make a fraction of their coefficients. What's that going to be? 1/2. Very good. Remember that there's an imaginary 1 right there. Okay. So I've got both my vertical asymptotes and I have my horizontal asymptote. Now let's do the x-intercept. And x-intercept is what? Numerator equal to 0. Very good. So I'm going to set what I was trying to do earlier, x minus 1 times x plus 1 equal to 0. Now it's that time. X equals 1, x equals negative 1. So I've got 2 x-intercepts too. And then now for our y-intercept, I like to go back to the very beginning. So my horizontal asymptote, my y-intercepts, I like to go back to the original problem. And I look here, if you plug 0 in for x, 0 squared is just 0. So I've got minus 1 on top. And then 2 times 0 squared is still just 0. So I get negative 8. So my y-intercept is negative 1 divided by negative 8. Positive 1/8. Very good. Y equals positive 1/8. All right, let's go graph all those pieces and see what happens, okay? So I've got vertical asymptote at 2 and negative 2. So dashed line there, dashed line here. Horizontal asymptote is at 1/2, so somewhere between 0 and 1. So right about here is fine. x-intercept is 1 and -1. And then my y-intercept is positive 1/8. That is somewhere between 0 and 1/2. So as long as you just put a dot somewhere between that 0 and 1/2, you're good. Yeah, Melody. Okay, good question, or good thought. Let's see what happens and maybe that'll answer your question. I've got 3 points right here. When you have two vertical asymptotes, the part in the middle is always going to be a parabola, and it depends if it's going upwards or downwards based on where your points are. The way our points are, it's going to be a downward, a concave down parabola right here. It's always approaching your asymptote, so that's why it's getting closer and closer to my asymptotes, but it hits all my points. Now, there's a couple different ways that we could do this. You can figure out where we go next, where the other little C curves are. I'm going to tell you that it's always catty corner again to where we were. So if we're in the bottom middle, the next two are going to be in the top left and right. So we're going to have a little C curve up here. We're going to have a little C curve down here. They're both in the top. Now, if you were confused, you could always plug in a number and see if that's true, right? I could plug in like 3. Oh, I did not mean to erase that. I could plug in like 3 or 4 or truly anything bigger than 2 to see if that will be up above that 1/2 line or if it will be below. So if you want to just kind of let me walk through this for a second, I'll show you. You can plug this in if you forget where those lines go. So let's say I'm going to plug 3 in for x squared. And all I'm doing right now is proving that that answer is going to be up in this part of the graph, okay? So let me get my calculator out. So let's see, 3 squared minus 1 is 9 minus 1, which is 8. And then 3 squared is 9. 9 times 2 is 18. 18 minus 8 is 10. So I've got 8 divided by 10, which is about 0.8. That's bigger than 1/2, right? 0.8 is bigger than 0.5. So that means that it's above this line right here. So that's why that C curve is above that line. We could do the same thing with -3. However, I'm going to argue it's going to be the same number because if we square -3, it's still positive 9 minus 1, which is 8. And if we square -3, it's still positive 9, blah, 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 blah. Okay. You don't have to plug in. I just want to show you that as an option to understand what is going on. Instead of just blindly trusting me, you can plug in and see that that's where those C curves go, is in the top, not in the bottom. Okay. All right, Millie, did that answer your question?
Well, I just want to like kind of get the things on the message.
Yeah.
I'm just.
Good. Horizontal asymptote, you look at the exponents. So I've got an x squared on top and I've got a 2x squared on the bottom. And now I ask myself, how do those exponents relate? 2 and 2 are the same. So that means I'm just going to look at the coefficients in front of those. Yeah. We'll do other situations, but that is truly the most common one. So most common, look for that. I'll show you special situations after this. Okay. Now, if you flip your paper over or scroll down, these are the new problems that you just added. So if you don't see these problems, then you know that something's wrong. I've got 2 graphs on here. I want you guys to try and graph those on your own or with a neighbor. And then we're going to talk about all of this limit notation stuff. You don't know how to do that yet. I'm going to talk to you about that. It's not hard, but it's new. So you can try and graph all of those, find your intercepts, find your axes, or find your asymptotes, all that fun stuff. And then we'll do limit notation.
Same quick reminder, please take a second.
Oh, thank you. I'm sorry.
Thank you.
Did I forget in your class already too?
Yes.
I always forget attendance. I appreciate that Mr. Fuji's so nice about it. Mhm. I think all of you are here today, that's why I haven't taken attendance. All right, I'm gonna start doing the work now on these. You wanna check in? All right, I've got my first one drafted on the board right now, so if you wanna check that, I will go do my second one in a second. Again, you don't know what to do with these, so just make sure your graphs are good for both of them, and then we'll talk more. Anybody questions on this first one? I'm gonna go do the second one now. So for the y-intercept, you plug 0 in for all the x's, so
Okay.
2 times 0 cancels. H is positive. And my VA is negative.
No, H and negative.
No, I think H is positive too.
Yeah.
VA is negative, H is positive. And my intercepts, X is negative 1/2, Y is positive 1/2. I got my number 3, I've got graph number 3 on the board now as well. So let's check in on that one. All right, how are we doing with the graphs? Everybody good with the graphs? All right, what I want now is I want to talk about this notation that we've got going on over here. I don't think I've shown you anything like this yet, have I? Does this look super familiar? No, okay. So this is what we call limit notation. So that LIM right here, that stands for limit. And this is kind of where we get into like the pre-calculus-ness of this course. We don't do a lot of what I would call pre-calculus. A lot of it's just algebra stuff. A limit is a calculus idea that like as you approach something, what happens, okay? So when it says limit f of x, and then it has x arrow infinity, basically what that's saying is what is the limit? Or what is, I guess, what is y approaching? What is y getting closer to? What is y doing? Whatever word you want to use, what is y doing? What is y approaching? What is y getting closer to as x gets closer to? And it's whatever number or whatever thing is in that box next to the x.
Maybe do this remove, not exactly this, but I think my favorite graphics thing.
This is a fancier version of what we did. We said like as x approaches negative infinity, what does y approach? It's the exact same thing. It just looks a little bit different. So I want to use this kind of limit notation. So it's something that you guys have seen. But yes, conceptually, you guys have done this before. And the answers here are just going to be one number. It could be infinity, it could be negative infinity, it could be 0, it could be 5, it could just be just any number, okay? So let's go look at the picture. We're going to look at the graph. So as x approaches infinity, so as my x gets bigger and bigger, like as I go this way on my page, we're thinking about what is y? What's my y doing? So I'm going to trace my graph as I get bigger and bigger and bigger. What is my y getting closer and closer to? 1. It is getting closer and closer to that 1. It's getting closer and closer to that asymptote line, right? And that asymptote line is at 1. So as x approaches infinity, the limit of my function is 1. We're approaching 1. Okay, let's do the same idea with negative infinity. As x gets smaller and smaller, so as x goes this way on my graph, we're thinking about what's our graph approaching now. So I'm going to trace this left side of the graph. What are we approaching as we get closer, bigger and bigger, bigger, or as x gets smaller and smaller, smaller, what are we approaching? 1 again. Ooh, you may be sensing a pattern. Let's go look at the next one. Let's go do those infinities with that next one again. So that was positive and negative infinity. Let's go do positive infinity and negative infinity with the other graph. And then I want to see if you guys think of a pattern. Okay, so I'm on number 3, and now it says, what's my limit of my function as x approaches positive infinity? So again, I'm going this way to the biggest x numbers that I can think of. So what does y get closer and closer and closer to? 2. Feel like you feel it. Now we're gonna do the same thing, but now x is going to approach negative infinity, so we're gonna go this way. What is my graph doing as I go as far left as possible? 2. What pattern are you kind of noticing? Going to the horizontal asymptote every single time. Every single time we're looking at the infinities, at the end behavior, essentially, it's going to approach the horizontal asymptote. I'm just going to write HA next to it. Every time you have that infinity, it's going to approach that horizontal asymptote. And I'm going to go write it on A and B up here too, just HA. My infinity ones are going to approach my horizontal asymptote every single time. Okay, now there are 2 other ones though that don't look the same. These now we're talking about 2 and it says 2 with a plus, and then it says 2 with a, it should just say minus. You can cross off that little 1 up there. It should just say minus. Should have deleted that before I gave it to you. What's important about 2 on this graph? What's so special about 2? My vertical asymptote, right? So that means that something happens at my vertical asymptote. Okay, so let's think about it. When it has this 2 with a plus sign behind it, that means that we're coming at 2 from the right side. So we're coming from the right side. So we're going to be to the right of 2, and we're going to get closer and closer to 2. Okay, so that means if I'm looking at my graph, I'm going to be approaching from this way. So essentially I'm going to be like kind of centering in at 2 each time. This time we're gonna start from the right side. So we're gonna come from the right and get closer and closer and closer to 2. So as I get closer and closer and closer to 2, what am I approaching? Positive infinity, good. It's going up and up and up and up forever. The x is 2, my y is gonna approach positive infinity. It's getting bigger and bigger and bigger. Okay. Now, similar idea, now we're gonna approach it from the left side. So now we came from the right side, now we're gonna come from the left side and see what happens. What's my y doing, what's my graph doing as we get closer and closer and closer to 2 from the left-hand side? Negative infinity. We're going to negative infinity this time. We okay with that? Okay, let's do the same idea with the one below, okay? This one also, it says -2 this time. Well, what's -2 in this problem? It's my vertical asymptote. So that's probably an important thing we're looking at. Remind me, what does that little plus sign mean? From the right, good, so we're coming from the right, so let's do that one first, so we're gonna go towards -2, but we're coming from the right, so we're going this way. What is my graph doing as we approach it from the right? It's approaching negative infinity, it's decreasing, it's approaching negative infinity. Remember, these answers are always numbers, always a number. And then similarly, we're gonna now do it with the negative, and the negative means we're coming from which side? Left side. So same idea, come from the left. And it's approaching what? Positive infinity. Do you think we can make a pattern about these ones when we start with a vertical asymptote? What's my answer gonna be? It's gonna be positive or negative infinity. I don't want to make any other guess because I don't know if it's gonna start positive or start negative infinity. All I'm gonna say is that if we are approaching a vertical asymptote, your answer is either positive infinity or it's negative infinity. So when we're approaching a vertical asymptote, it's either positive infinity or it's negative infinity. You don't have to draw on your picture, that's just me helping you see what we're looking at. But like, you don't need to draw the arrows. It's one of those things that's hard for me to illustrate to you guys because there's not a lot of work. So I'm just trying to like trace, like, this is what I'm watching, this is what I'm looking at. So you don't need to draw on here at all. You can just know, okay, it's the horizontal asymptote or it's positive or negative. Okay. All right, let's see if we can get 2 more of these problems done. That'll give us more wiggle room later in the week, okay? Let's look at number 4. I actually want to graph this in the calculator first before we graph it by hand. Because it's kind of a funny one and I'm just not quite sure what it's gonna look like. And let's graph in the calculator since we have that time. And since we have the calculator in our hands. I'd love to do 4 and 6 before we're done. So I've got this x squared minus 9 and then 3x plus 9. So we'll go x squared minus 9 divided by 3x plus 9. And then I would just be at a standard window. I'd go zoom standard. If not, are you going to be like this today?
How do you say your number?
Go to zoom and then go to 6, which is Z standard. I don't know why that panicked, so let's see if I can get it to work now. Okay, just didn't it all. Now, I might have too many parentheses, but you do need a fair amount of parentheses to make sure that your denominator is all in the denominator. Because if you have no parentheses, it might just think it's dividing by 3x, and then it's got like a plus 9 up next to it. So you may need more parentheses than you think that you need, okay? I'm gonna go graph. Okay, weird, we put a parentheses, we had a division, and it gives us a line. Isn't that kind of odd? let's go solve it out and see why that makes sense that this is a line. Did you guys get a line on your paper too? Okay, I'm gonna be very honest, I had a line on my key and then I panicked and thought that was wrong, so I was like, let's graph it together as a group, but it is a line, so, and we can confirm why it's a line, so. What I wanna do first is if we can factor it, we're going to factor it, so first things first, let's factor that top, what's the numerator gonna be? X plus 3, x minus 3. And what's the denominator gonna be? 3. Good, 3 times x plus 3. Okay, we have not dealt with this yet, but I now have terms to cancel out. If you have the exact same thing on the numerator and the denominator, it's gonna cancel out, it's gonna go away, so that x plus 3 is going to cancel. So I am just left with this x minus 3 divided by 3. Okay. Now that looks really ugly, but we can make that into separate fractions, right? We can do x divided by 3. Well, that's going to be 1/3 x. And I can do negative 3 divided by 3 and get -1. Are you confused here? Are you confused here? Okay, good, because this is the easier one to do. What's easy here is that if you have two things in the numerator, they're both being divided by 3, so we can separate it out by just dividing each part by 3. So I take x divided by 3, and x over 3 just like doesn't help me with anything, but that's the same thing as a 1x over 3. And then we can move that x instead of being on top to being multiplied next to it. Then when you do that, the constants, and you do -3 divided by 3, that's just canceled out to just be -1. Okay. Yeah, it's nice. So I'm gonna argue there are no asymptotes here because this is our equation. Once I do my canceled form, that's when I would look at the denominator for my asymptotes, the numerator for my x-intercept. This equation is just a line. I now have a linear equation, so I'm gonna graph that line. The only thing is that canceled term does do something to my graph. Do you remember what the canceled term becomes when we graph it? Does anyone remember what that is? We haven't talked about it yet today. It's called the hole, so we'll have a hole at that point where those canceled values are. So we'll have a hole at x plus 3 equals 0, which is just x equals -3. Now, I don't usually make you plug in to figure out what that number is. What you can do and what other teachers might have you do is plug -3 in to the equation up here. I generally think it just will make sense where that point's gonna go, so I don't like to do that, but we can do that, just kind of confirm that right here. So I can plug -3 into that, so I've got 1/3 times -3 minus 1. Well, that's gonna be 1/3 times -3 is -1 minus 1, which is -2. So my hole is at the point -3, -2. I can graph that hole and I can graph this line. We've been graphing lines since freshman year. We can graph that line. As long as we make sure there's a hole where we need to have a hole, then we are good to go. Okay, so let's go graph. I've got 1/3 -1, so I'm going to start at -1. I'm going to go up 1 over 3, up 1, 1, 2, 3 over 3. I'll go one more. Up 1, 1, 2, 3, somewhere about there. And if you went down 1 and then over 3, that would be where my hole is. That's at -3, -2. So we'll just put a hole right there. A hole means that there is not a point on that graph. So we're gonna basically like connect the lines around it. And then it will extend after it.
Awesome.
Basically, it's just a spot, like an open circle on your graph. Now your calculator has a hard time showing holes, so when we graph it, you won't be able to like really see it, but there is a hole present there. The last problem I wanna do, I wanna skip number 5, because that's ones that like we can do, so like we've done, we can do that tomorrow. I wanna do one like number 6. Do you know why I wanna do one like number 6 together with you today? What's different about this? We will have to factor it. Bigger versus smaller, good. So it's my horizontal asymptote. Where it's going to be bigger on top versus and smaller on bottom, so we're gonna have to do a synthetic division to find a slant asymptote. Okay? Everything else will be the same, so like Macy said, let's factor it out. So we're gonna factor this, it becomes x plus 4, x plus 1, I think. And then x minus 2. Can you cancel anything? No, so are there any holes on this graph? No holes. If you want, you can make note of that. You don't have to, but if you want, you can make note of that. Now in this space, I'm gonna do my vertical asymptote like we have been doing, my horizontal asymptote, my x-intercepts, and my y-intercepts. Okay. We're gonna come back to the horizontal asymptote. We're gonna do the other 3 because they're just like normal, okay? So vertical asymptote, set that numerator equal, or set that denominator equal to 0. X minus 2 equals 0, so x equals 2. My x-intercept, I've got x plus 4 equals 0 and x plus 1 equals 0. So x is going to equal -4 and -1. And then last, y-intercept is you plug 0 in for all those x's, so 0 squared is just 0, plus 5 times 0 is just 0, so it's 4. And then 0 minus 2 is just -2, so it's gonna be 4 over -2. So y-intercept is -2. Everybody doing okay so far? Nothing has been new yet. Now we're gonna do something new. Since my exponent on top is bigger than the one on bottom, we're gonna do synthetic division. Okay. So we're gonna divide. We're gonna do our 2 is in the house. We're gonna do our coefficients 1, 5, 4, and we're gonna do synthetic division just like we did a ton last unit. Everybody's good so far? No, pencils down solving. When I solved, I got 1, 7, and then 18 was my remainder. This will not factor evenly. You will not get 0 as a remainder. I want us to ignore the remainder. The remainder doesn't matter to us, okay? What matters are the other 2 numbers. And that, after we did synthetic division, we're going down an exponent. So it was x squared. Now it's x minus 7. That is your slant asymptote. We're going to graph that line, and that will be our slant asymptote, whichever way it's going. Tonight. Oh, why is it x minus 7? Great question. X plus 7. I don't know why. I threw a negative in there. My fault. X plus 7. So let's go graph that. We're going to graph our slant asymptote. So I'm going to go to 7. Right. Let's see. Here's my graph going to be over here. I'm doing a little off-centered graph because I'm gonna need to go all the way up to 7. And I also need to see -4. So I've got a lot going on here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 7, 8, 9, 10. So my vertical asymptote is at +2. So let's graph that vertical asymptote at +2. And now I'm going to do my slant asymptote at y equals x plus 7. So I'm going to go up to 7. 1, 2, 3, 4, 5, 6, 7. Okay. And then I'm basically just going over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1. Oh, that's a little too far. Okay. And then I'm just going to dash line that all the way through, and I can extend it down in this direction as far as I want. And I can extend that vertical asymptote a little bit more too. Basically, instead of having just like a normal cross, we still have like 4 quadrants, they're just shifted a little bit, okay? So now I have like kind of 2 small pie pieces, like one between my hands and then one between my elbows, and I've got bigger ones between like my hand and my elbow. Okay, let's graph our x-intercepts to see kind of where are we gonna be putting these curves. So I've got -1 and -4. And then my y-intercept is at -2. Okay, that kind of curve parabola looks something like this. Oof, that was ugly. Let's try again. Something like that. It should be approaching the asymptotes. I've just drawn it a little bit off to scale, so I'm a little far from the asymptotes, but eventually it will approach the asymptotes. Now, what other area do you think we're going to draw the other curve in? Is it going to be 1, 2, or 3? 2, very good. It's still catty corner, it's still opposite of where we drew the last one. And this one, as long as you draw just like a little curve that's approaching both of your asymptotes, that's all I really want to see there. All right, that's it for today. We still have 2 problems, so you do not have 2.6 homework due yet. I'll assign it tomorrow, and we'll finish this and start 2-7 tomorrow. Also, guys, we're looking at a quiz middle to end of next week. So it's either going to be Wednesday, Thursday, or Friday. I know there's retreat next week, so just make sure that you communicate with me if you're going on retreat. Have a good time, but we'll get you fixed up. You're going on retreat. And then we're not looking at a test for this until middle of the following week. So we will test on this before Thanksgiving. Okay. All right. That's it.